Airport safety is an important part of aviation safety. It may sound strange, but it's true that every successful flight begins and ends at an airport. And that makes airport safety everybody's business. The pilot, the controller, the line technician, and countless others all play key roles in making sure that an airport is safe. But the prime responsibility rests with the airport operator. While some hazardous airport conditions develop virtually instantaneously, others are gradual. So it's important to have an airport self-inspection program that identifies specific areas so that small problems don't have a chance to grow into major safety hazards. A successful self-inspection program should have 4 components: a daily inspection of physical facilities, continuous surveillance of certain airport activities such as fueling operations, a periodic condition inspection program for such things as surveying approach slopes, and special inspections during unusual conditions or situations. This presentation addresses that part of the self-inspection program involving the daily inspection of physical facilities. But there are some references to items that require continuous surveillance, periodic condition inspections, or special inspections. 9 subject areas have been identified and are covered as part of this daily airport inspection videotape. The subjects are pavement, safety areas, markings and signs, lighting, navigational aids, obstructions, fuel farms, snow and ice conditions, and construction on airports. Daily inspections are recommended for wildlife hazards, public protection safeguards, and aircraft rescue and firefighting facilities, equipment, and vehicles. But those subjects are not specifically addressed in this presentation. Also, we're dealing with a generic airport, so there may be elements at your airport that should be included as part of your daily inspections that are not addressed here. Before we address the 9 subject areas, let's review what inspectors should know, what equipment they should have, and what procedures would be in place for a good daily self-inspection program. First, the inspector must be knowledgeable about the airport and should know the location and types of its various facilities. He or she should also be familiar with the standards applicable to the airport as specified in the FAA Advisory Circular Series 150. Advisory circulars are provided and maintained by the FAA to assist airport personnel in the safe operation of their facility. Due to changing requirements and new technologies, advisory circulars should be reviewed on a continuous basis to ensure that only the latest information is utilized for airport operations. And the inspector should know and use correct radio communication procedures and techniques. As for equipment, the inspector should have a vehicle with a beacon and a 2-way radio, and should be supplied with checklists covering various inspection areas. And while formats of checklists vary, the important thing is to develop a checklist that is useful for your specific airport and its operation. A sketch of the airport should accompany your checklist so that the location of problems can be readily identified. To make the daily inspections effective, there must be procedures for reporting deficiencies so that they can be corrected. There should be established procedures for reporting through the Notice to Airmen or NOTAM system, a way of acknowledging that corrective actions have been taken, and a method for removing NOTAMs that are no longer applicable. That then is the essence of a good airport self-inspection program. But now, let's take a look at the specifics. The condition of pavement surfaces is an important part of airport safety. At the minimum, a daily inspection should be performed of all paved areas used by aircraft. During this inspection, you should look for pavement lip problems, cracks, potholes, spalling, bumps and low spots, edge dams, foreign object debris, and rubber contamination. Pavement lips, the area between the full-strength pavement and shoulders, or paved shoulders and safety areas, should not be more than 3 inches high. But while 3 inches is the maximum acceptable height of a lip, it should be no greater than necessary to allow water to drain from the pavement surface. This is particularly important because lips higher than 3 inches can damage aircraft tires and landing gear. Pavement lips at runway ends need careful examination since they are particularly susceptible to jet blast and prop wash. The lips on the sides of runways and taxiways aren't usually affected by jet blast or prop wash, but water draining from the pavement can cause side lip problems, so it's important to make sure that these lips not be more than 3 inches high. Looking for cracks is another part of the daily inspection routine. Some cracks, like this one, are actually wide enough to cause control problems for a plane. Most cracks are small and seem insignificant, but the problem with small cracks is that they are usually the beginning of serious pavement problems. For example, when water from storm runoff drains into cracks, the structural integrity of the pavement base and the subbase can be damaged, and eventually, major cracks may develop. Consequently, all cracks found should be reported so that repairs can be made quickly. Potholes, like cracks, tend to grow. So during the daily inspection, you should be on the lookout for potholes of any size and report them so that they can be patched. Generally, any hole that is more than 5 inches across and 3 inches deep can cause an airplane to lose directional control or damage its tires or landing gear. After you report a problem, follow up to make sure the repair has been performed. Pavement spalling, where the surface is actually breaking up, is another area of concern. Spalling can easily result in the loss of directional control or even cause foreign object damage, or FOD, to an aircraft. For example, both jet engines and propellers can be badly damaged by pieces of loose pavement. Therefore, if you see any areas of spalling during your inspection, they should be reported so that the loose pavement can be removed. By the way, FOD isn't limited to loose pieces of pavement. In fact, most FOD to airplanes is caused by sloppy ramp practices by airport tenants. Inspectors should pick up isolated foreign objects on the spot, but substantial amounts of debris should be reported so that it can be cleaned up as soon as possible. Also, any foreign object debris found during inspection should be noted on the log, and where tenant responsibility can be readily determined, that tenant should be notified. Any bumps or low spots in the pavement should be reported, since bumps can affect directional control and obviously water can collect in a low spot, causing ponding. Touchdown zones on runways used by large aircraft are particularly susceptible to developing ruts. Standing water on runways is particularly dangerous since it can cause aircraft hydroplaning. And water also tends to obscure pavement markings, especially at night. Even small ponds of water are potential problems, since during winter they can freeze, resulting in patchy ice conditions that can cause uneven braking action. Ponding can also attract birds, which can pose a serious hazard to aircraft operations. Low spots aren't the only cause of ponding. Vegetation growing next to the pavement surface can block or slow down water drainage, creating edge dams. The ponding on this taxiway was caused by an edge dam. Needless to say, if you see any ponding during your daily inspection, it should be reported. But it's also a good idea to occasionally conduct a special inspection for ponding immediately after it has rained. While the inspector should look for rubber contamination during the daily inspections, rubber buildup is so gradual that there is not much noticeable change from day to day. So, periodic inspections should be conducted to look for rubber buildup. There are 2 simple tests that an inspector can use to check for rubber contamination. First, if the texture of the pavement feels smooth rather than gritty to the touch, or if rubber can be peeled off the pavement surface. The runway touchdown area and the sections of pavement next to them are the most likely areas for rubber contamination. Consequently, pavement markings can be obscured, and the rubber can also make the pavement slippery when wet. In summary, the important things you should be concerned about during your daily pavement inspection include improper lips that are more than 3 inches high, any cracks because they could be the start of serious pavement problems, potholes, remembering that from little potholes bigger ones grow, breaking up of the pavement or spalling, low spots which can allow water to collect, edge dams created by vegetation along the side of the pavement, foreign object debris on runways, taxiways, and on ramps, and finally, rubber contamination, that slow buildup which can eventually make for obliterated markings and slippery runways. Knowing what to look for on or around the pavement can go a long way in making your operation a safe and efficient one. As an inspector, you should be familiar with the dimensions of both runway and taxiway safety areas at your airport. While the dimensions vary depending on the type of aircraft that use the runway, a A safety area is defined as a rectangular area, usually turfed, centered on the runway centerline, and includes the runway itself, as well as the runway shoulder. Taxiway safety areas have a similar definition. Normally, the safety areas should be able to support equipment for snow removal, firefighting, and rescue operations, and also to be able to help the occasional airplane that leaves the pavement and protect it from major damage. Therefore, the safety area must be cleared, drained, and graded, and have in it only that equipment that the FAA has determined as being absolutely necessary. The safety area next to this runway, for example, has several holes and ruts which could seriously damage an aircraft's landing gear if the plane left the pavement. Edge lights, signs, and navigational aids are examples of equipment that are permitted in a safety area, but the bases for them should be at ground level and they should be mounted on frangible couplings so that they can easily break away if struck by a moving aircraft. And safety areas must be well drained because standing water keeps the ground soft and consequently makes it impossible for emergency vehicles to move easily. The inspector should also note any area where water runoff has caused ruts. Remember, only authorized equipment should be in a safety area. It is not a storage area. Construction and maintenance operations can cause very real safety problems. Contractors have been known to quit work for the day, leaving piles of dirt, open trenches, tire ruts in the safety area, or even manholes uncovered. Maintenance workers have also been known to compound existing hazardous conditions. So a special inspection should be conducted just before a runway or taxiway is reopened, following any construction or maintenance that has been performed in or around that safety area. Any time an aircraft has left the pavement and entered a safety area, a special inspection should be made to ensure no ruts or holes have been made by the aircraft's tires or by personnel or equipment during the recovery operation. After any significant weather event, at airports equipped with the Engineered Material Arresting System, or EMAS, inspections must be performed to the manufacturer's specifications or in accordance with the airport's inspection guidelines. There are 4 primary areas of consideration in inspecting a safety area. First, make sure there are no ruts, holes, or humps. Second, ensure that only objects absolutely required are on the safety areas, and that those objects which must be above grade are mounted so that they can break away if hit. Third, make sure that the bases of objects have not been exposed as a result of erosion. And finally, look out for construction and maintenance activities and be sure that no hazardous conditions have been created because of that work. Remember that discrepancies should be noted on the inspection checklist so that any hazardous conditions can be corrected. Airport marking and signs provide important information to pilots during landing, takeoff, and taxiing. To avoid pilot confusion and disorientation, all airport markings and signs should be standardized. During the daily inspection, the pavement markings should be checked to be sure they are correct and clearly visible to pilots. Physical changes to pavement markings occur slowly, usually from the effects of sun and weather. Consequently, a comprehensive inspection should be performed periodically to check for peeling, blistering, chipping, and especially for rubber buildup in the touchdown zone areas. And since markings are least visible at night or when the pavement is wet, it's a good idea to occasionally perform special inspections after dark or immediately after a rain. In addition, airport signs should be checked to make sure the proper sign is in the right place, that they can be read easily, and if lighted, that all lights are working. Let's review some typical pavement markings and signs. With one exception, runway markings are always white. Since markings will vary depending on the runway category, it is important for inspectors to be familiar with the markings at their airport. For example, a typical visual runway may only have the runway numerals and a center line, but a non-precision instrument runway will also have a threshold marking. And if a runway is 4,000 feet or longer and is used by jets, it should also have fixed distance markings. And a precision instrument runway will have touchdown zone markings and side stripes, as well as the non-precision runway markings. Taxiways, which are always marked in yellow, have center lines and may also have double edge lines. The taxiway center line is extended onto the runway to provide a lead-in. Enhanced taxiway markings are intended to provide additional visual cues to taxiing pilots to help them identify the location of a runway holding position. All taxiways that intersect runways have yellow hold position lines, 2 solid lines perpendicular to the taxi center line on the holding side, and 2 sets of broken lines on the runway side. If there is a holding or run-up apron at the end of the runway, the hold position lines should run across the apron. When a runway or taxiway is closed to aircraft operations, it should be marked with a yellow cross or X. Runway thresholds are not always at the beginning of the pavement. Sometimes, landing thresholds are moved so that aircraft have more clearance over obstructions in the approach area. The proper marking of the paved area between the beginning of the pavement and the threshold will be dependent on how this area is intended to be used. The threshold is considered to be displaced if this area is still available for landing rollout from the opposite direction and for takeoffs. The paved area prior to the displaced threshold is marked with white arrows and arrowheads. If the area between the beginning of the pavement and the threshold is not to be used for landing or takeoff, the threshold is considered to be relocated and is marked with yellow chevrons, meaning that it is not available for any aircraft operations, including taxiing. But if the area may still be used for taxiing, a yellow center line is used with 4 yellow arrowheads to indicate the relocated threshold, which is marked in white. In addition to pavement markings, signs provide pilots with important information. Since most signs are located in runway or taxiway safety areas, they should be mounted on frangible couplings on bases that are no higher than ground level. Sign tether anchor hardpoints must be provided on one sign mounting leg above the frangible breaking point. One end of the tether must attach to the sign structure, and the other end must attach below the frangible point on the coupling to either one of the leg mounting bolts or an independent bolt in the mounting pad. Signs must have a minimum of 1 tether per module. For sign arrays, a tether must be used at either end. Sign inspections should include checking for readability, making sure that vegetation or other obstacles are not blocking the sign, ensuring that each sign has the correct lettering or numerals, and if appropriate, making sure all lights are working. A sign should be adjacent to every holding position, and preferably on the left-hand side. The holding position sign has a red background with white lettering, which shows the runway designation arranged with numerals relative to the respective threshold. While red and white holding position signs are the current standards, changes in Advisory Circular 150-5345-44 call for a black outline to be added to the white legend on runway signs. Consult the most recent advisory circular for complete information. A red sign with a white ILS shows the critical area for an instrument landing system. Hold position lines should also be on the pavement next to the ILS sign. The standard for informational signs that provide taxiway guidance or destination information is black lettering on a yellow background. Pilots are advised of the distance remaining to the end of the runway by signs with black backgrounds and white numerals. Let's take a look at some good and bad examples of pavement markings and signs. For example, this runway marking is neither clearly readable nor is it in good condition. But in contrast, a pilot can easily read this runway marking, which is standard configuration and standard color. This taxiway centerline could cause confusion since it was not clearly visible. But here's the same taxiway after it was repainted. Note that double-edged lines have been added to the side to mark the taxiway from the adjacent apron. Occasionally, pavement marking is inadvertently omitted after construction or maintenance operations. Consequently, a special markings inspection should be performed before the pavement is reopened. In summary, during your inspection of airport marking and signs, you should be checking for standardization of color, configuration, and readability. And your sign inspection should also include the operation of lighting, the correct orientation of signs and individual sign panels, and for damage or erosion around mounting stakes or bases. Remember, airport marking and guidance signs provide essential information to visual cues to pilots during critical phases of flight, as well as during ground operations, and therefore they are important elements of any airport self-inspection program. At night and during periods of low visibility, lighting is vital for safe airport operations. Lights come in different shapes, sizes, colors, and configurations, and can be located either in the pavement or along its edges. So let's run a checklist for the daily airfield lighting inspection. Alignment is particularly important for high-intensity runway edge lights because the lenses are designed so that most of the light goes toward the end of the runway, with very little toward the sides. If a high-intensity fixture is properly aligned but still seems dim, its lens might be improperly mounted. During the inspection, make sure that the runway lights are working at each of the brightness steps, and if the lights are power controlled, they should be activated to ensure that this system is working. Any missing or broken lenses should be reported. Report vegetation or snow obscuring any light, as well as lenses that are dirty. Inspectors should be familiar with the color coding of airport lights since pilots rely on them for specific information. Any lights that are the wrong color should be reported at once. Runway edge lights are white, except on instrument runways where yellow replaces white on the last 2,000 feet or half the runway length, whichever is less. This creates a caution zone for landings. In the opposite direction, the yellow runway lights are white. When viewed from an approaching aircraft, threshold lights are green to indicate the beginning of the runway. But when viewed from the aircraft taking off in the opposite direction, threshold lights are red and taxiway edge lights are blue. Edge lighting for a displaced threshold is somewhat complicated since the area between the threshold and the pavement area is not considered to be usable runway for approaching aircraft, but it is considered to be runway for other operations. For this reason, it's necessary to use several split lenses. For example, lights along the pavement edge in this area show red toward the approach and yellow in the opposite direction. The lights on each side of the displaced threshold show green toward the approach. The light closest to the pavement shows yellow in the opposite direction, while the outer 3 are blacked out. And lastly, the 8 lights at the end of the pavement show red in all directions. In pavement lights, which are installed on some instrument runways, are also color-coded. For example, touchdown zone lights are white. Looking from the landing threshold, the runway centerline lights are also white until the last 3,000 feet of the runway. Then, the white lights begin to alternate with red for the next 2,000 feet. And finally, the last 1,000 feet of centerline lights are red. In the past, taxiway centerline lights were all green, but under a new international standard, the green lights will alternate with yellow ones on the runway side of the taxiway hold line. Now remember, a lighting inspection should also include the edge light mounts to make sure their breakaway feature isn't compromised. It's important to report any mounting stake or concrete base that's above grade level, and remember to report any excavation around the edge lights that has not been backfilled. Your daily lighting inspection should make sure that all lights are in place, are working, and are properly aligned, that the lenses are not broken or obscured by dirt, vegetation, or snow, that all lights are properly color-coded, and that the bases for all edge lights are at grade level. The lights should be operated at each of their brightness steps, and when they are designed to be radio activated, this feature should be checked as well. Lighting is a very important airport safety element. Without it, at night or in poor visibility, pilots lack a major source of vital information. Depending on an airport's size, navigational aids may vary from a simple windsock to a very sophisticated instrument landing system, which allows operations to the lowest minimums. Operation, maintenance, and inspection requirements of electronic navigational aids are not covered in this presentation. While some visual aids may be owned by the airport operator, others may be owned by the FAA, the military, or others, and it is the owner of the navigational aid who is responsible for making sure that it is working properly. The inspector should include these aids in his daily inspection and report deficiencies to the owner so that they can be repaired. The daily inspection should concentrate on the visual navigation aids owned by the airport operator. For example, the rotating beacon, the segmented circle, the wind cone, runway end identifier lights, REILs, and the visual glide slope indicator system, VGSI. The rotating beacon shows the airport's location and therefore should be checked daily to make sure it is working properly. A segmented circle should be clear of vegetation, dirt, or snow so that it can be easily seen from the air, since it helps the pilot find the wind direction indicator. And also, erosion can displace circle segments, so you must be alert to this possibility as well. Wind direction indicators, such as the wind cone, give pilots important information for landing or takeoff. The cone should be inspected daily to make sure it swings freely, and if lighted, that all lights are operating. Runway End Identifier Lights, or REILs, provide the pilot with a rapid and positive identification of the approach end of a runway. Daily inspections of REILs should ensure that each light is flashing. Since REILs are placed in safety areas, they should be mounted so that they can break away, and their bases should be at a grade. And any obvious misalignment of the light fixture should be reported. Periodic investigations should be made to check for proper horizontal and vertical alignment. Visual glide slope indicators provide pilots with valuable landing information. VASIs, PLASIs, and PAPIs are common types of visual glide slope indicators, and as part of any daily inspection, should be checked to see that their lights are in working order. And since they are located in safety areas, they too must be breakaway mounted and the bases at grade level. Any obvious misalignment of the support structure should also be reported. And as a part of your periodic condition inspection, the correct angle of the glide path indicator should be checked using the proper alignment equipment. Remember that the daily inspection of navigational aids should concentrate on the visual elements that are owned by the airport operator, and the inspection should focus on examining the aid to see that it is working properly, making sure that it is not obscured by vegetation or snow, that any associated lighting is working, and that there are no obvious misalignments of the navigational aid. Obstructions on or near the airport can be serious safety hazards and could require issuing notices to airmen, the displacement of the landing threshold, adjustments to the landing minimums, or even the shutdown of navigational aids. Trees and other vegetation near the airport that could affect glide path angles should be surveyed as part of your periodic inspection. While permanent obstructions are a concern, the daily inspection should concentrate on a visual check for new construction underway near the airport that could affect airport operations. Particular attention should be paid to cranes being used at nearby construction sites. Any person proposing construction near a public-use airport must notify the FAA, and there have been several instances where the FAA has received notification of building construction but has not been advised about tall cranes being used. Clearly, a crane can be as much of a hazard as a building. Upon notification, the FAA performs an analysis to determine what effect the proposed construction would have on aircraft operations and what measures should be taken to mitigate any negative effects. Many builders, however, are not aware of these notification requirements, so it's important for the airport inspector to take note of any construction activity near the airport that might require FAA analysis. In summary, a good airport inspection program should ensure that any construction noted by the inspector has been reported to the FAA. Also, any faulty off-airport obstruction lights should be reported to the obstruction owner so that they can be repaired. Airport operators have the responsibility of making sure fueling operations comply with regulations and are conducted in a safe manner. Continuous surveillance of fueling operations should be practiced. Periodically, fuel trucks should be inspected, but the inspection should concentrate on the fuel farm and should include security, fire protection, and general housekeeping. As far as security is concerned, access should be restricted to only those persons authorized in the fuel farm. So the inspection should include checking to make sure there are appropriate signs and that all gates are closed and locked. In addition, all lights in or near the fuel farm should be checked. And the inspection checklist should include making sure that no smoking signs are posted, since fire and explosion are the two biggest worries. Fire extinguishers should be readily available and should be checked to be sure they are BC rated and that their seals have not been damaged. And finally, the inspection should include checking to make sure the bonding wire and clip are available and that they are in good condition. Also, check for the hydrostatic test approval tag. These tests should be conducted every 5 years. A poorly maintained fuel farm is a dangerous one. It should be clean and not littered with debris, and there should be no vegetation growing in or around the area. Obvious leaks or fuel spills should be noted and reported. The pipes in the fuel farm should be clearly labeled and correctly color-coded to indicate the type of fuel. In summary, security, fire protection, and general housekeeping are the 3 primary areas you should be aware of during the fuel farm inspection. When it comes to protecting against fire, nothing can be taken for granted. It's no secret that snow and ice can create very hazardous conditions at an airport. It's the inspector's job to identify dangerous conditions so that they can be corrected. Or if the problems are so severe that corrective measures aren't possible, the inspector's observations become the basis for issuing notices to airmen, or NOTAMs, or even closing the runway. As an inspector, there are a number of conditions you should be looking for. First, there's ice or snow on pavement surfaces, which could cause reduced aircraft directional control or even alter braking effectiveness. Then, there's the possibility that lights and signs might be obscured by snow or damaged by snow removal operations. Snow banks or snow piles next to the pavement can create problems with wingtips or engine clearances, or they may block access routes dedicated for airport rescue and firefighting vehicles. And foreign object debris, particularly chunks of ice, may be left on the pavement after snow removal operations, and snow that accumulates around electronic navigation aids may interfere with their signals. Since winter weather doesn't run on any regular schedule, one daily inspection probably isn't enough to make sure your airport is safe. Several special inspections may be needed until the situation is back to normal. Inspectors should report any snow or ice on pavement so that crews can either remove it or use approved abrasive materials. Removing snow or ice from the pavement is one thing, but if that operation covers runway or taxiway lights or airport signs, another hazard has been created. Lights and signs that a pilot can't see don't mean much. Check to make sure nothing has been covered over or damaged during snow removal operations. Remember that the inspector should also check to make sure snow removal operators have not blocked any access routes that are dedicated for airport rescue and firefighting equipment. Similarly, snow depth should be checked in critical areas around electronic navigational aids to ensure that the snow doesn't interfere with the signal. Looking for various foreign objects after snow and ice removal operations should be an important part of your special inspection. Even sand from ice control operations can accumulate on the pavement. So obviously, any debris should be removed before aircraft operations are permitted. In summary, your ice and snow inspection checklist should include identifying slippery pavement, making sure all lights and signs are visible, being alert to snowbanks on or near the pavement, making sure snow doesn't block access for airport rescue and firefighting vehicles, checking to be sure snow hasn't interfered with navigational aids, and looking for foreign object debris on runways and taxiways. But when any hazard created by winter conditions can't be corrected immediately, appropriate NOTAMs should be issued. Safe aircraft operation can be affected by construction activity. When there is construction at your airport, the daily inspection should focus on it to be sure that a high level of safety is maintained. Continuous surveillance are the watchwords. Any construction project should have a safety plan as part of its plans and specifications, and the airport inspector should become intimately familiar with it even before work begins. Although the safety plan may identify the resident engineer, the contractor, or someone else being responsible for construction safety, it's the job of the airport inspector to be able to recognize any hazardous conditions. A construction crew is usually not familiar with aircraft operations or other airport procedures, and consequently, a number of hazards can be created. Inspectors should make sure that the contractors and vendors comply with prearranged vehicle parking requirements, and that vehicle movements on aircraft operating services are kept to an absolute minimum and are restricted to well-defined paths. Stockpiled material must be in approved storage areas and should be definitely clear of aircraft operations, navigational aids, and other critical areas and facilities. Construction materials must also be stored in such a way as to keep them from being moved by wind, jet blasts, or prop wash. Construction areas should be identified with conspicuous markings and lighting. While a given area might be obvious during daylight hours, special night inspections are necessary to ensure that lighting is adequate to keep aircraft away from the site, and at the same time, make sure that no construction equipment is parked outside the prearranged areas. In this case, note that the marking is clearly visible, that numerous flashers are installed, that equipment is confined to a designated area, and that debris is not a problem. Construction markings should be lightweight to minimize damage to an aircraft, but at the same time be secured tightly enough to withstand wind, jet blasts, and prop wash. If construction will close a runway, the proper material should be available to install a yellow X. Though not particularly durable, snow fence is one way to make an X. It's lightweight and easily moved. Tall but relatively low visibility construction equipment like cranes and pile drivers should be marked and lighted to make them more visible to pilots. In summary, remember that construction crews are not always aware of the safety hazards that they might create. So when construction is underway at your airport, keep a sharp eye out for irregularities, proper marking and lighting, storage of materials and equipment, and unauthorized use of runways, taxiways, and aprons. These are all areas you should be particularly concerned about.